Well, let's talk about one of the big OEMs. Vestas has received the type certification from DNV on the V236 15 megawatt offshore turbine. They that turbine is using 115.5 meter long blades. Holy cow. And it's designed for a place like the North Sea off the coast of the US and maybe over even in China. It has a low cut-in speed, Rosemary, 3 meters per second, and a cut-out speed of 31 meters a second. So that's a pretty wide range.
Yeah, it's very broad.
Isn't that a really high cutout speed?
I think so too. Yes.
'Cause I saw an article recently, someone tagged me on LinkedIn, this article that was about, some record being broken from a wind turbine. I think it was a 16 megawatt wind turbine operating at rated capacity for a whole 24-hour period, basically. And I said, well, yeah, okay, it's the world's largest wind turbine and it operated at rated capacity for 1 day. Therefore, obviously, it was going to break the 1 day record. Like, it's just a logical conclusion of the fact. The article was like, and the turbine does this, 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 and this. And like, those are all the same thing. That's one exciting thing that you've just, just written a whole article restating that, basically. And it was a bit of a LinkedIn argument because someone's like, oh, you're such a party pooper. Like, I bet that you would go watch the 100 meters final at the Olympics and say, oh, what's the big deal? They're just moving their legs really fast. Like, well, yeah, okay, but like it's one cool thing that can run 100 meters fast. You don't then say, oh my God, they also broke the world record for 90 meters and 91 meters and 92 meters. It would be the same kind of thing, like it all follows. But anyway, I digress, because one of the other claims of the article was that, and this, revolutionary new wind turbine can survive a hurricane or, whatever kind of storm it was. And I looked up the wind speed, the rated wind speed. I'm like, that is just a very normal rated wind speed and cutout wind speed, all very normal, but it's in the 20s. So this one, couldn't you legitimately say this is like a storm-proof wind turbine? I just think that's a higher cutout speed than normal. I mean, not every storm. I'm not saying that there's not a storm on Earth that could destroy it, but it's clearly rated to, certified to withstand stronger winds than your average wind turbine. Let's say that. I don't want to be the one that is getting all hyperbolic now and about a wind turbine, but this is a robust, sturdy wind turbine by the looks of it, as well as being huge.
So how do they get to the 31 meters a second? Is it because they have more pitch?
No, I mean, every wind turbine can pitch all the way around. That it's normal that you would pitch to make them the minimum aerodynamic load. It'll be a stronger blade, and stronger bearings and stronger, like everything that it's attached to, it has to be stronger all the way down, stronger, foundation as well. The certification standards require that it can withstand a maximum gust wind speed, and that the turbine manufacturer doesn't get to decide what that is. But that's not the operational cutout. That is up to the turbine manufacturer to decide at what point do we say you can't generate power anymore. You have to just feather your blades and pinwheel probably, and ride out the storm without falling over, but not generating power anymore. And this turbine is generating up higher. And I mean, there's good power to be got from those high wind speeds. So if you're in an area with a lot of storms, then I think that would make you'd see more annual energy production from having the higher cutout wind speed.
And they are too, because keep in mind what markets this was also designed for, not just the North Sea, but also Taiwan, where they also have, some pretty, strong typhoon winds and stuff like that during different parts of the year. They're also intending to use this quite a bit in Brazil, if Brazil is ever going to be a market, I guess. Potentially Colombia as well. So there are, and both Brazil and Colombia, if you're familiar with the region, I mean, the reason why people are actually excited about Brazil's offshore wind market is because even if you just look at their onshore wind in like Rio Grande do Norte and that kind of area of the country, if you go offshore, you have very, very low turbulence and you have very high sustained winds. And I mean, it's it's a turbine designer's dream. It's an operator's dream out there. So the turbine is kind of perfectly designed for that type of application.
So I found the numbers now, and Rosemary, I completely agree with you. This thing is this Vestas V236 is going to be super robust to be able to regularly run in those high wind speeds. In the IEC standard, the highest wind class is 1A, which is 10 meters per second annual average wind speed at hub height, or the extreme 50-year gust is 160 miles per hour. That's the highest. That's the highest rated one. Now, if I'm switching to my other screen and I'm going to go to the Saffir-Simpson, and I'm going to say that wrong, Saffir-Simpson Hurricane Wind Scale. This is from the government of the U.S., National Oceanic and Atmospheric Administration, NOAA. Their class 5 is a major sustained winds is 157 miles per hour or higher. So a class 5 hurricane is sustained at the same speed that is a class 1A wind turbine at a 50-year gust is the max. So that's why I worry about if we just put these same types of turbines in the Gulf of Mexico, that some morning we're going to wake up with a beach full of fiberglass.
Yeah, the Gulf of Mexico is not the right place for this, but along the Atlantic coastline, it would be in the U.S. The hurricanes don't tend to be 4s and 5s, South Carolina, North Carolina, Virginia up. They're 2, 3s generally, right? So it'd be a good place there.
Yeah, cold water.
Right, it loses energy there. It's cold. But this, all right. So and what's the 115 meter blade mean, Rosemary? Is that like super difficult blade to build because of its length, or is it a 2-piece? Is it a 2-piece or 1-piece? I assume it's 1-piece.
Yeah, I assume it's one piece. I don't know if any of the really long blades that are 2 pieces. The 2-piece blades are all in the in 60s, 70s meters sort of length. Yeah, I mean, for offshore wind, you don't have that same issue with transport, right? You make your blade factory right next to a port, and then you put it on a ship, and away it goes. It never needs to go under a bridge or around a corner or anything. So it's not such a big deal, and the blade structure is so important. So you would really struggle to put a split in there somewhere and make it strong enough to withstand 31 meters per second storm. But the blade length, it's super duper ridiculously long. So let's not downgrade it. These really long wind turbine blades, they're the largest single piece man-made structure anywhere. There's no part of a bridge that is bigger than a wind turbine blade, or part of a building, a skyscraper even. So yes, they're gigantic. However, these aren't the longest blades in the world. There are people up, in the 120s, or at least they've got, paper designs and blade molds for that length. I'm not sure that they've actually installed turbines with 120 something meter blades, although maybe they have and I missed it. So super long, but not world record breaking.
How many turbines do they have to sell before they break even on that particular design? Is there a rough number?
It's usually about 300, Alan, for something that big. When you consider like all the non-recurring engineering, plus all their like supply chain startup costs and stuff like that, normally when we've done that type of analysis for companies in the past, it comes out to be about 300 units. Now, that said, that was also at commodity prices that were a lot cheaper relative to turbine size, a few years back. So we could be talking about 350 to 400 units. That said, I'm actually looking at our Intel Store data platform, and based on both kind of unconfirmed orders and stuff that's probably in negotiation, and again hasn't actually been formally publicly announced yet, there's actually a total of about 95 gigawatts, or about 6,300 units where these turbines could be used. But again, a lot of these also include, like, a overwhelming majority of that is actually in Brazil, where they just use the Vestas V236 as a placeholder for their permitting application.
So you're saying 6,300 that could go into actual permitted areas that exist right now?
if these become firm orders. So again, keep in mind that all of this is just, again, in our project database where we track everything into the future, as far out as governments have kind of publicly reported, data that for projects that are in the consenting queue. Anybody who's utilized the Vestas V236 as their kind of quote unquote kind of placeholder turbine. And this includes, so I'm looking at the countries we've got, Denmark, Germany, Italy, Poland, the US, Taiwan, South Korea, etc. There's markets all over the world where, these turbines could be used in project sites. But again, we're, 95 gigawatts is a big number, and that's also out towards like 2035, 2040, kind of a time frame. None of that, I don't think, has been firmed up yet. I think they only have one firm order so far or maybe two firm orders in Europe so far for the 236. So just keep that in mind as we talk about it. But I mean, this could, to be blunt, like we're actually projecting that Vestas will overtake Siemens Gamesa in offshore market share at some point in the future because of this turbine and any derivatives of this turbine platform. So this is the fact that they got it certified. I think you're going to see more deals become formally announced in the near term, especially again in the U.S. Some of the projects where they were kind of lined up as the preferred turbine vendor. Some of those projects are going through some of the resubmittals at this point of their their power offtake contract requests, and they're going to have to retender. Some are going to be for newer projects. Keep in mind also, Vestas has a pretty big desire to have a big footprint in a market like Australia, where they're really starting to get their act together now. I think they've got something like 36 gigawatts, according to the latest estimate we've got, of projects in the permitting and consent queue down there at this point. So, there's pretty big global opportunity for this turbine.
Yeah, but Phil and Rosemary, the turbines are so big. How many can they possibly produce in a single year? 100? 100 seems like a lot.
Maybe, but how much money you got? Because, yes, there are diminishing returns in terms of like maximum, factory capacity. But at the end of the day, if they are going to get firm orders, I could see them putting up a dedicated factory in Australia. I could see them putting in a factory in South Korea. Definitely see them putting a factory in Brazil. And they'll continue to supply throughout Europe from Denmark. So, yeah. And I think they're even looking at Taiwan at this point, but they're not going to sell any of them in China unless something dramatically changes at this point. But yeah, they could establish a decent amount of annual manufacturing capacity. A single factory could actually churn out about 200 units a year if they designed and built it right.
Yeah, and on the blade side, you would have to make about say it's 300 units to break even, right? So you're going to make about 1,000 blades before the company starts to see any sort of revenue return. 1,000 blades, do you really, at that point, you kind of have to commit, right? 1,000 blades, and then you can figure out how well the blades are performing. Is that a real risk, right? Because of the time frame, like it's a couple years out. You have this big demand. You don't have a lot of history on those. I'm thinking it's 115 meters.
Just because that's your break-even point doesn't mean that you're definitely going to get to that point. I know that definitely in the past, it's a matter of prestige as well. These really big turbines, especially, in the past, people have really wanted to have the world's biggest turbine, the world's longest blade. And so there have been in the past designs that have been made to mostly just fulfill that PR need to be able to say, we have the longest blade in the world, and then use that to sell other other turbines, other blades. And so I know that there were projects of really long blades at the time that did not break even. They wouldn't have made the volume. But either way, even if you're only making a single test blade even, you still need a fair amount of commitment, because you need to get that blade mold made. You need the same mold whether you're making one blade or 100 blades or more. And then beyond that number, it's a matter of how quickly do you want to pump blades out, because like for a shorter blade, you'll usually have in a factory a single line, like a single mold spot is going to put out one blade per 24-hour period, like clockwork. And some of the bigger factories have multiple lines, so they're putting out multiple blades each day. But for these really long blades, I know when they were, when around 100 meters was new, it was certainly the case that it was, not a day per blade. It was, maybe that by the time they got everything dialed in, it was more like a week or two for a blade. Presumably in the, decade since we got to that point, it's come down. But I'd be really surprised if you can make a 115-meter long blade, if you can close one of them every single day from any kind of factory, just because, they're so big. Laminates are so thick, just the time frame for everything pushes out, and you can't necessarily just throw more people onto it to make the problem smaller. So yeah, I haven't actually worked in a factory that was making blades of this length, so I'm kind of speculating, but I'm going to assume that it takes multiple days for one of these blades to come off. And of course, the factories need to be really big. It needs to be obviously more than 115.5 meters long. And then also you've got to think about the blades need to be able to rotate. And if you've got the normal blade manufacturing process where you make it in two halves, like clamshell halves, two blade molds, and then you close one. And also after the blade is finished, when you're repairing it, you need to be able to rotate it so that it's, you can get at all parts of it, reach all parts of the blade. So, if you've got a maximum chord that's 5 meters, 8 meters, whatever it is, your roof needs to be a lot higher than that. So, the buildings are really big. And so if you're having multiple lines, then you're going to end up with huge factories. And like I said before, that you want to place them conveniently to access the port. So it's not like there's just infinite land available. So I think that companies would be a bit more cautious about their scale up plans for a blade of that size compared to, a 50-meter blade. You can just chuck lines in as you feel like it, basically, without risking as much.
That's my opinion too, Rosemary. I know a couple of months ago there was a discussion Vestas had. It was some sort of webinar. I think I heard it or a podcast where they're talking about building new factories, and each factory is about $500 million. Like, wow, that's a huge investment if you've already put all the money into certifying a new wind turbine to start then putting literally billions of dollars down around the world to make this new machine. That's a huge risk. And Phil, is there a projected ROI on this? There must be a number somewhere. I haven't seen anything published by Vestas, but you would think you would like to get your money back as soon as you can. But like Rosemary points out, the scale of this makes it hard.
Yeah, and what also complicates it, Ellen, is what we've just been kind of talking about. As Rosemary's indicated, you're going to get a point of diminishing returns where you can't just throw more money and more people at the factories. As I was indicating before, like, yeah, you can build multiple factories, you can build multiple lines, but at the end of the day, your ROI is ultimately determined by whether or not you have a firm enough order book to make the capital commitment to do the factory, and then you can actually deliver on that order book with the level of quality that you need to. Because if you end up doing a ton of blades and then there's a lot of rework, because maybe the factory you have in Taiwan or Australia isn't performing at the same level of quality as the Danish factory or whatever, therein lies the problem of that's a pretty big thing to blow. Like, if you don't get that right, and you have to start the blade over from scratch or something, potentially, you're talking about scrapping, blades that are $1.5 million plus, $2 million each.
Maybe Vestas will get smart and acquire part of Loop and just send Rosemary to the different factories to make sure they're built right. Somebody's got to do it.
I'll wait for that call.
Oh no, we'll put a Vestas factory in Australia.
Oh, that's true. Right down the road, right in Canberra. There you go.